Question 5. So, for part 1, calculate the acceleration of P while it is in motion and the corresponding tension in the string. Well, okay, so we're using the kinematic equations, so we know U equals 0, V equals 1.4, and S equals 0.2. So substituting into V squared equals U squared plus 2AS, we can work out that A equals 4.9. Now, if we just look at P alone and use Newton's second, so F equals ma, our net force, well, we're going downwards here, so the 0.3 g is greater than the tension, so 0.3 g minus T is our net force, and this equals the mass of 0.3 times the acceleration we've just worked out at 4.9, so our tension is 1.47. Now for part 2, we need to work out to find the value of m, so we really need another equation to help us out. So if we look at Q now, and again use Newton's second, F equals ma, well now we're going upwards, so the tension is greater than mg, so our net force is T minus mg equaling ma. Rearranging this, I can get m equaling T over A plus G, so substituting in, because I know T, I know A, and of course I know G, I've got m being 0.1 kilograms. Now for part 3, calculate the greatest height of Q above the ground. Well, we're starting off at 0.2 anyway. Obviously, as P comes down and Q goes up, as P crashes into the ground, Q will naturally have gone up another 0.2 anyway. So the only bit, the extra bit we need to add on is the little bit as the tension in the string goes, and Q just goes carrying on up, fighting gravity just a little bit more until it suddenly stops. So what do we know about that final bit of journey? We know that our initial speed of Q is going to be the final speed of P as it crashes into the ground. So the initial speed of U will be 1.4. It carries on going up and up and up and up and up until it reaches its maximum. Its maximum V equals 0, and we know the only force that it's fighting is gravity, so A equals minus G. So substituting into V squared equals U squared plus 2AS, I'm using X here because it's this specific distance I'm looking for, we can work out that X is 0.1, so overall the distance above the ground, Q, is 0.5 meters. Now for point 4, the tension when P is in motion. So we've got these two tensions as well as the weight of the pulley. So 0.5 g plus 1.47 plus 1.47. However, for part B, I've called it part 5, but I really mean 4, that's 4A and 4B. For 4B, when P is at rest on the ground and Q is moving upwards, well, the tensions have now gone, so we're just left with the 0.5 g, so 4.9 newtons.